Good day friends, welcome to my channel lecture series on power electronics. In this lecture, we are going to simulate a buck converter. A buck converter is a DC to DC converter. We'll open a new file. The components required for a buck converter are the MOSFET, the gating signal for the MOSFET, the DC voltage source, a resistor, a capacitor, an inductor, a diode. We can get a diode from the elements power, switches and diode. The diode should be placed in this direction. Then we need probes for the measurement. We need one on the input side, one on the output side. Now let us connect all these elements using the wire. So let us connect the gate to the gate of the MOSFET. Let us connect the voltage input also to the MOSFET. Then we will connect the diode, inductor, capacitor, resistor, all these things connected to the negative of the supply like this. This probe is for measuring the input voltage. This probe for measuring the output voltage. This is the basic buck converter circuit. And here we are going to actually reduce the voltage from 36 volts to 12 volts. So here we have to give an input voltage of 36 volts. "36 volts we will be giving as the input, and let it be given name as V in or Vs. We will give it as V in and display it is here 36 volts. Now we are going to give the gating signal for the MOSFET. We want to get a voltage of 12 volts from 36 volts. And the switching frequency is going to be 25 kilohertz. So we will give the attribute as 25,000 volts. The switching points are actually defined by the duty cycle. Because we have a 36 volts input, we want to get 12 volts. The duty cycle is obtained by dividing, getting the duty cycle by these two voltages. And just for now, we will take the duty cycle what we get corresponds to 120 degrees. So we'll just have it as 120 here. The explanation of this I'll be giving in detail in the next design of buck converter. So here we have two switching points for which we have given 0 and 120. Then we have the inductor. The inductor value is also designed, and it is designed as 166.75 microfarad. So we'll give it a value 166.75. Instead of microfarad, we make the letter U. Then the inductor is also having a value 166.75. The capacitor has a value of 160 microfarad. So let us make it as 160 U. And now the resistor also is chosen a value 160. The resistor is given a value of say 10 ohms. Let it be as 10 ohms itself. So this is the circuit, and this is designed for getting a 12 volts output from 36 volts input. Let us now have the simulation control placed here. Let us have the time for say 0.04. Now let us run the simulation and see. And before that, we can rename the probes. That is, we can have this one marked as V in and V output instead of VP1. We can have it as V. Yes, okay. We'll display it in source voltage, and this also we will give the name as say V output. Let it be displayed. Let us now simulate and see. We can add the output and the source. We can choose the different colors, have the thickness as 3 for both. Then we can mark it as okay. Now we are seeing the output. The input is 36 volts and output is becoming 12 volts. This is how we simulate a buck converter using the PSIM. We can actually get the design values, which will be dealt in a separate lecture. Thank you.